Cool. All right. Hey everyone, FusedVR
Hassan here.
And super excited to be back. This has been 4 weeks?
Yeah.
4 weeks since we've been live?
We need our live stream fix.
Oh, wait. Do I have the preview going on? No, that's from you.
That's me. You guys.
We're Gucci. I was like, wait, what? Where's the sound coming from? Cool. So, yeah. We probably haven't done Vive Dev in about 4 weeks now. The last time I touched the Vive was about 2 weeks ago. And then, like, a week ago, I was, like, building this, and I was like, wow. I've missed a Vive Dev.
It's really fun.
Being on AirKit for a while is, like, it's cool, but, like, it's not the same as the Vive.
Yeah.
So, excited to be back, and, yeah, expect, starting from now, a variety of content. I think last week you saw that I posted that, like, Udacity podcast vlog type of thing. So maybe it's some sort of stuff like that. I've got a really cool Pokemon Go video coming up next week and a bunch more cool content. So
yeah, get
excited. We're back finally after this hiatus and excited to be doing this tutorial.
Yeah, and I'll be in the chat, so if you have any questions about what we've been up to or where we're going, stuff about AR, just drop the questions in there and we'll answer them, or we could answer them live right here too.
Yep, cool.
All right,
I'm gonna dive into it. So let me show it off first. So if you've seen the teaser or if you saw what I was just showing right before the stream, this is a really small game built with VRTK. You might be able to see that in the hierarchy. We go controller. Here we go. Here's a little gun. This is literally the exact same model as VRTK. Or sorry, exact same gun, and then I just swapped out the model. Apologies to any like super hardcore Blade Runner fan that this is not the same model that is actually used in it, but we didn't have that much time to make this, so sorry about that. And basic premise, as you might have seen in the teaser, is pretty much try to differentiate between humans and replicants. We figured that was probably the easiest thing to actually build and show to you guys. So we have two types of models, although I'm seeing a lot of humanoids, not really replicants, which is actually probably a good thing. And so they're all just coming in. Wow, so many humans. Nope. Nope. Where did the replicants go? So this is like a 50-50 chance, although anything random, you never know what you're actually going to get. But clearly today that they just want to spawn humans, not replicants like the teaser. I will wait probably about 5 seconds. If I don't see any replicant, I'm just going to shoot everyone. Doesn't matter if you're human or replicant today. Okay, you're done. But yeah, okay, so we have the gun here. It's the exact same bullets as VRTK. Nothing super fancy going on. I don't even really do any counting of any kind. It's just a matter of just shoot and kill, really, and then you can play your own game of making sure you only hit replicants. I am really surprised. Let me just throw that gun. I'm really surprised there are no replicants. That random generator is messing with me right now. And I will double check to make sure that I added the replicant model, but that's really bizarre. Let me drag this in here. That is human. Okay, let's see. So we have the spawn enemy script right here. That's really what's kind of controlling everything that we want. So you have spawn points, which is the transforms of wherever we want to spawn. Specifically, that's a couple points over here, and then we have two agents, human and replicant. So just like we've kind of been doing in our recent streams, what we've done is we've put this project on GitHub. So if you want to follow along with kind of what I'm showing, and if you want to make any modifications, you can do that. But this kind of just serves as our starter template to explain kind of what we've built and how you can build the same thing. So yeah, let's just kind of dive into this. So here we go. You can already see VRTK right here, loud and proud. This is the gun from VRTK. This is actually, I believe, it's in one of these example scenes here. Probably, you can search for it, but it's in here. I just copied and pasted it. Just works beautifully using the VRTK SDK manager with the SDK setup. You can see that a lot has been changing recently since the last time I tried VRTK. You can see Daydream, Oculus VR, and simulator support. Obviously, we're using SteamVR, which I've kind of dragged out over here. So you have all of this. and the VRTK scripts, which just control the left and right controller. So really well done as far as just kind of separating this out so that it's really more of a VR toolkit and not a Steam VR toolkit, which is kind of where VRTK started, which is really cool. Here's the gun. Just open this. So that's all the mesh components. That's from, I found this on the asset store. One of the reasons why it's not the same gun as actually Blade Runner. And you can see here, this is the VRTK gun script with the fixed joint and swap controller on there. So you can control this with both hands. If you want, you can customize any of this so that currently in the setup is you grab with the grips and shoot with the trigger. You can swap, I don't know if you'd want to swap that around, that's kind of weird. But you might want to just switch this so that like you pick it up and it just sticks there to your hand and replaces the hand model. So that's one thing you could do with this script right here. Let me go ahead and open it up. Actually, I haven't opened it up, but because there was no reason to. But I believe this is built off of one of the VRTK scripts. Let's just open up good old Visual Studios. Any second now. I don't remember if I've updated Visual Studios or not. Because yeah, I've been doing a lot of Unity dev on a Mac, not a PC, which I'll be honest, and I hate the Mac dev. I am not a fan. Okay, so yeah, it's a VR interactable object, and there's really not that much code in here. Really, all you're doing is like whenever you want to start using it, fire a bullet, and then really simple bullet script. Again, you can update this however you want. You can probably add some like modifiers here. Actually, they're already here, like bullet speed, the lifetime of the bullet, like what it hits, any of that type of stuff. So pretty straightforward to use as far as that's concerned. Again, we didn't really have to build it because it's already built for us. So yeah, so that's the gun. Nothing terribly fancy there, and that's really the main thing we used VRTK for, was getting that gun down and not having to worry about building any of the core functionality of the first-person shooter. And so then let me zoom out here. This is I believe I've used this in a stream before. This is the skyscraper. It's broken. It's a giant city, really just a bunch of low poly assets with some decent textures. And I disabled the fog, although there is a fog layer that you can use to make this kind of feel a lot more like a Gotham-like city. But if you don't want that, I've kind of disabled that. Actually, you can see some layers already, which is kind of that thing right there. So yeah, so that's basically kind of the scene setup. And then as far as the replicants, and that's probably the main thing that I added to this, was that's done via the spawn enemy script. So let's go ahead and open that up. So standard mono behavior, we have access to the player, we have access to spawn points, which is specifically where the enemies spawn, and then we have access to what Navmesh agents we want to spawn. So as you can tell already, we're using the Navmesh that's built into Unity. And actually, let me go ahead and open the navigation panel so that you can see that. There we go. Agent areas. There we go. So we're specifically only really doing it in this area around the player, because we don't have any player movement. There's not really a need for player movement. Although if that's something you want to add with teleportation or walking or whatnot, we can. And let me know in the comments, or not in the comments, in the chat if you want to see that. But all we've done is just kind of bake this mesh. Specifically, we're not even really using these top level meshes over here. We're just using this area. So what it allows us to do is, if we spawn something here, it's instead of like walking through this building, which would be kind of weird, we're gonna have it kind of go around and then attack us from the side. Same thing if we want to go from here or this alleyway. That's all built in, which is really neat part about Navmesh. It kind of gives you that AI movement without having to do anything crazy to actually make your agents walk around. So that's what the Navmesh looks like. And yeah, I just imported this in, so expect that the Navmesh is already built. And so yeah, so that's the Navmesh itself. Let's go back to script here. So really, all we've done is, this is just spawning enemies like the actual title of the script says. So we're using an enumerator for start. So if you don't know what that is, it's basically a coroutine. It allows you to pause during your current execution and wait till whenever you save for it to wait for. In this case, we're telling it to wait for 2 to 4 seconds and some random range in between that. And so that basically allows this to keep starting. Another way we could have done this is using void start, which is kind of traditionally the way you do it, and then calling start coroutine to start it. But if you want to simplify your code and, like, say in this specific case, you really only have that IEnumerator thing that you want to call, then you can just build that into start. So it's kind of a nice little hack that's built into mono behaviors. And once we have that, you can say here we have while true, so it's just constantly looping and then spawning enemies every 2 to 4 seconds. And so we get a random spawn point. We sample the mesh for where that spawn point maps to the Navmesh, and we get a random agent, get a random position that's tied to the Navmesh, and we say that you should be looking at the player specifically. To not get some weird rotations, we tell them what the up vector is, and that instantiates our Navmesh, and then all we have to do is tell it where the player is, and it starts dashing towards the player. Now, if we go to one of these prefabs, really the only difference between either of these agents is the material. So we can go, if I pull this out, go here, I think it's one level down. This is, because it's rigged, we get a skinned mesh renderer that has the material tab here. We get 2 little materials, specifically here. All I'm doing is really, if it's a replicant, we're going to use the red material. If it's a human, we're going to use the kind of standard pink material. So that's really the only difference in there. You might have noticed, go to here, if I go, there's a Navmesh agent. So if you've never seen Navmesh agents before, what they do, actually let me drag it out so you can actually see it. So let's focus on it. They're basically represented by a little cylinder. It's what allows a Navmesh agent to kind of attach itself to our Navmesh, which is this blue area right here. And once we have that, it sits basically on that mesh and allows us to move around that. The AI calculations kind of calculates a path once we set the destination, which we do right here, which is basically wherever the player is. So the offset is basically to accommodate for any heights that your mesh has. You can set the speed, how fast you want it to rotate, how fast it should be accelerating, whether or not should it break as it gets closer to its destination, and then how big it is. So really a lot of tools to play around with, and that makes it kind of versatile as far as if I want some AI to do a different thing, I can tweak these parameters to make it do that. I can also set the destinations differently, however I want. It's a really, really versatile tool. That's why I really like Navmesh agents. There are also some other tools on the asset store you could use, but I think Unity is going to be spending a bit of time to actually make this a lot better. If you go to GitHub, you can actually find a new tool set for Navmeshes. I'll find out a little later, but the idea there is that you can bake Navmeshes at runtime, which is actually what we're using in our game, which is a really, really cool tool. There's more features that come with it, and if you guys want, I can pull it up. Just let me know in the chat. So yeah, that's what a Navmesh agent does. There's also our being script, which I've added. Let's go ahead and pull that up. Really simple. All we're doing here is on trigger enter, so whenever our Navmesh runs into another one, if it is the player, as opposed to, like, say, the city or whatever else, then we destroy the game object. You can play death animations here. You could add a counter to see if it's like human or replicant. This is basically where you'd add that code. So a really simple script. We can flesh this out a lot more or keep it really simple. It kind of depends on what effect you're going for. In our case, we're just kind of making kind of the bare bones thing that could make a video look cool. In the actual trailer, that death counter was added in post, but that's something you can add in-game also if you want to kind of just keep track of a counter for how many replicants versus humans you've killed. And yeah, that's pretty much all I have to say about the being script. Again, any questions, let me know. And yeah, that pretty much, the only other thing is this fancy little robot guy comes with some walking animations, which saved me so much time. It's unbelievable. Animations take a while to make, believe it or not. And yeah, so it's just kind of this little anim walk thing. I don't think it actually comes with any. It might have an idle, but it doesn't look like it does. So that, I mean, that's what makes it look somewhat decent, is the fact that it has this little walk animation. Yeah, so that's pretty much all that there is in this actual project. There's not much here. It's just spawning and letting you shoot. You can keep track of whatever you want in order to make it a full-fledged game, but this is really the core crux of what needs to be implemented in order to get a really bare-bones Unity Dive VR project working. Nothing fancy, nothing terribly complicated. Most of the stuff is like tools that Unity provides, so that's what's really exciting about it. Hassan, do we have any questions that popped up? Or
we're just talking about what people are building. So
nice. That's always fun to see. I like, as much as like we're busy, I love seeing short little videos of what people are actually building, because that's really cool. I think DevPuppy on Twitter showed me something he's building for ARK, which is like a little, it kind of suits his name, which is a little puppy or cat simulation for ARK, which I thought was really cool. Cool. So in that case, let me pull up that actual thing, the Navmesh, the dynamic Navmesh. There's actually a lot. Here we go. There's a lot of stuff that Unity is putting on GitHub for whatever reason. I'm not sure why. There's like editor VR. There's Navmesh components. Octtree. Post-processing, well, that's also in the asset store. Oh, wait, what? I didn't know that there was an XR line renderer. That's pretty cool. That basically serves the purpose of like our tilt brush tutorial, where instead of like being a 2D line renderer, it renders it in 3D as like an actual geometry. So that's something that's coming down the pipe. Basically, if you want to know what Unity's actually building, even if it's not built into the editor, this is where you go. They also have a lot of things on Bitbucket, which is like a substitute for GitHub. Surprisingly, a lot of like what you would think would be like hidden code is accessible there. So that's also a really cool place to look at. Steam runtime. I don't understand why all of this is like, as much as you'd like to think that it's private, it's really not. It's all public here. And I'm surprised that there's 18 hours ago. When was that? I guess Friday. Okay. But anyway, here's the Navmesh component. You can see it's broken down into 4 things. The benefit of this really is that you can build things at runtime. That's really the huge, really huge win, actually, is that you can build things at runtime. Specifically like Navmesh surfaces or anything like Navmesh modifiers or like links. You get that all through having this and the actual package in your project. So if you haven't taken a look at this, highly recommend. Yeah, layers, geometry, render meshes, physics colliders. There's nothing actually like specific to, like, this is more of just an add-on. It doesn't break anything with navigation whatsoever. So you can still use the baked version in, but you don't have to with this. And that's really the cool part, because I guess one thing I didn't mention is, in order to like get navigation to work properly, what you need to do is make your floors navigation static. You can also you can make them like pure static. For these purposes, there's really only one light in here, which is the directional light. So there wasn't really a reason to actually make the actual directional, or like to bake in the directional light, because it's a relatively simple light. And sometimes, believe it or not, sometimes having a runtime directional light is actually more performant than a baked directional light, which is kind of counterintuitive, but it sort of makes sense depending on like how realistic you want your lighting to be. If you want like super hi-fi like 8K textures on your light maps, then yeah, that's going to be probably more performant costing than a runtime light. And it's surprising that that's the case, but something to point out anyways. But like it could also be cheaper if you're like going for like, let's say I don't know, what would be a good size? 512 maybe. 512 could be better. 1024 could be okay. A bunch of different things to play around with light mapping. It's so cool to see. It's like really cool to see how the graphics pipeline works. It's probably, I feel like not a lot of people talk about the graphics pipeline, but it's one of those things that is like, once you like get down to like how the software meets the hardware and like how shaders work, that stuff is really, really cool. Really, really cool. So yeah, if there aren't any questions on this per se, I'm just gonna hop in and play this.
And we're good on time too, so
oh, it's already 10:30. What? When did 10:30 come by? Cool. Yeah, if questions pop up, I can answer them later at the end of the stream. But I mean, chats. I love to see an active chat. So if it's not questions here, definitely I want to hear more about the projects later. But yeah, let me actually. We can swap to creator chat time because I think that will be a lot of fun, and that gives me time to actually read the chat and see